Greetings everyone. Today we're going to explore the zero and negative rules of exponents. Now you do need your foldable for this, but you could jot it down in your notebook. You will have to flip around a little bit if you do have the foldable. All right, first turn to the zero tab. Here is the rule. This is already written on your foldable. The rule says that no matter the base, no matter what it is, a, b, x, 5, 10, if you take it to the zero power, it automatically becomes a 1. Every time. Every single function. I could write my name to the zero power. It's still going to be 1. I could write 326 to the zero power. It's still 1. I could write the beginning of the alphabet to the zero power. It's still 1. Let's talk about the why. Why is it automatically 1? Why is this even a thing? Well, think about it. Don't need to write this down, but let's talk about if I was to expand this, right? If I had 2 x's on top and I had 2 x's on bottom, right? And I simplified, well, x divided by x cancels, I'm left with a 1, right? Okay, but let's also approach this from a division rule, the quotient rule, which we've already watched the video for. The quotient rule says when dividing like bases, you subtract their exponents. Well, what's 2 minus 2? 0. Anything to the 0 power, well, I have to still get that answer of 1. That's where it comes from, because if I divide anything by itself, it's 1. That's a concept you understand. If I actually subtract and get a 0, well, it still has to be 1. So let's take a look at this little example. If I was to simplify this, 2 over 4 is the same as 1/2. Numbers are numbers, don't change your rules. Anything divided by itself is 1. Anything divided by itself is 1. So my answer is just going to be a 1/2 here, right? Because anything subtracted to the 0 power is 1. So let's actually go to your notes and let's jot this down. All right. Key thing we also have to keep an eye out for is negatives. All right. 45 to the 0 power is 1. Now, if you ever forget this rule, guess what? Your calculator will help. If you type in 45 to the 0 power equals, it's going to give you 1. But take a look at example 6. See how this is different? That negative is not included under the exponent. So it's almost like I have a negative 1 times 45 to the 0 power. So that's like negative 1 times 1, because 45 to the 0 power is 1. So we actually get negative 1 for an answer. So maybe put a star by that. That's something to keep an eye out for. Let's look at this last one. This last one also says that the negative is not included. So it's like I've got a negative 1 on the outside. We're timesing by 45 to the 0 power, which is 1. So we still get negative 1. So when would I get a positive 1? If the whole thing is to the 0 power. That would be a positive 1. So let's stress that in your notes here. Example 8, we tried to show you how do they look different. So negative 5 to the 0 power is 1 versus the negative 5 not being included, which means I get negative 1. Okay, that's how they're going to look different. All right, let's try simplifying this example 9. I'm not doing anything to the 2. Nope, because I got to take care of this. What's 4 to the 0? 1. What's 2 divided by 1? 2. So sometimes it allows you to simplify even further. Ooh, we've got 3 pieces here, right? If I was to draw dots, I've got 3 pieces. 8 to the 0, 1. X to the first stays x to the first. Y to the 0, 1. 1 times 1 is 1, and I have a single x remaining. I would also accept just the x. Let's try this. We've got 2 dots, so 3 pieces. Negative 4 to the 0 is a solid 1. The m squared doesn't change, and the n doesn't change. All right, that's why I have that very few examples, because it's 1 no matter what, right? We have to memorize that. So let's jump and spend more time on the negative rules, okay? If I have a base like x that's to the negative a, all right, it still means I've got x multiplied by itself a amount of times, but the negative actually kicks it to the bottom, right? This is in the numerator, and now it's in the denominator. So let's apply it to numbers here. That example's written there for you. If I have 2 to the negative 3, I know that's an 8, but the 8 gets kicked to the bottom. Let's explore why. Why is that? Okay. Let's expand. I want to show you the why. So if I have 2 x's on top and 3 x's on bottom. We did this before, right? The quotient rule. The quotient rule, I let you take a shortcut. And the shortcut was which one's bigger? So that's where it stays, right? But you'll notice the x is on the other side. It's on the bottom. So how do I apply this with subtracting? Let's say you don't keep the bottom one. Let's say you straight subtract from the top. That would mean y is my base. 6 minus 15 is my exponents. That would be y equals negative 9. We don't keep negative exponents, and I know the bigger one was on bottom, so that 9 can get kicked to the bottom. So we've been taking the shortcut, but what if I give you a negative to begin with? How do I make it not negative? Kick it to the other side. So let's try this a little bit further. Okay, here's one where there's no solving, right? What that means is currently it's on the top. I don't want a negative, so I get to kick it to the bottom, right? Because imagine it could have looked like this. What if this was my original problem? Oh, 6 minus 9 is negative 3. Oh, but I taught you the cheat, and the cheat was it stays where it's bigger. See how those compare? Let's look at this one. Now let's do it with actual numbers. Okay, so right now I have this, right? I'm going to put it over 1 just to help myself write it out. 3 to the negative 2, I don't want a negative exponent. Kick it to the bottom. What is 3 squared? 3 times 3. That's 9. So my answer is 1/9. Let's try another one. I've got my fraction. The 3 stays. Can't do anything with it. There's no exponent. It is what it is. Y to the negative 5th. Oh, well, it's a negative on the bottom, so how do I get rid of it? I kick it to the top. Whatever side it's on, you move it to the other side to make it positive. All right, this one I technically have 3 pieces. All right, the 12, nothing special, it stays. The a squared, nothing special about it, it stays. The b to the negative 5th, ooh, it's a negative, let's kick it to the bottom to make it positive. Let's take a look at this one. I technically have 3 pieces. All right, piece by piece. X to the negative 4th. I can't have a negative, so I'm going to kick it to the bottom and make it positive. The 3, nothing special. It stays. The y, nothing special. It stays. And I need something on the top, so a 1. Ooh, look at all the pieces here. Oh my gosh. Okay, we have 1, 2, 3, 4, 5. Try to think of them as separate pieces, okay? So I've got my big fraction bar. First thing I notice is, let's just deal with regular old fraction. I have 12/8. What does that reduce down to? 3/2, right? Regular old fraction reducing. Now we have a couple of options. Next I notice, that's a negative. I'm going to kick it to the bottom. X to the 1st, it's already positive. I'm going to keep it there. Y to the negative 2nds on the bottom, I'm going to kick it to the top. Now if I look, 3/2 is taken care of, the y is what it is, but let's combine these two. When I multiply like bases, I add the exponents. Now, some of you might have thought of these x's differently. Maybe you kept the x and the y the way it is, but you said, wait a minute, the x is bigger on the bottom, so it stays on the bottom. 1 subtract a -4 is a 5. So some of you might jump straight from here to here, and that's okay. Let's try one more. I'm just going to make a ridiculous one. You can decide to jot this down if you want to or not. Doesn't matter to me. Let's say I've got this, and I'm just going to give you a whole bunch of options. This would be a good one to jot down, actually. Let's go 5, let's go y, 3, -3, and z, -2. Okay? All right, piece by piece. First step, I'm going to create my fraction bar. 15/35. That's going to go down to a 3 and a 7. Regular old reducing, right? Let's talk about the x's, all right? If I look at the x's, the bottom one is bigger. And I can subtract. 5 subtract -2 becomes 5 plus 2. That's a 7. Or if you think about that, if you kick this to the bottom, I'd have an x squared. So I'd have 7 of them, right? Let's take a look at the y's. Y to the 0 is 1. I don't need to write a 1. It's just 1. Y to the -3rd gets kicked to the top. Z. Let's look at the z values. Z is larger on top. 3 subtract -2 is 5. Or if you were to kick this one up to the top, right? If I kicked it to the top, I'd have z squared. Well, then I would add them and still get to 5. Think of each set of numbers or set of variables as their own little problem. All right? Okay, make sure, as always, you know the routine. Check out Google Classroom, see what your task is at hand. Let me know what questions you have, what you need, and until next time, have a good one.